Good afternoon, everyone, and welcome. My name is Andre Turin. I'm the Technical Director for DuRock. Thank you for taking time out of your busy day to hear me. I'm here to speak to you today about one of our systems. It's a non-combustible insulated cladding system, specifically PUCCS NC, for those of you that may already be familiar with it. So without further ado, I will jump into the presentation. The first thing I would like to do is to start off by letting you know a little bit about our company. For those of you that are not familiar with DuRock, we are Canadian owned and family operated. We've been at this business since 1979. So 2 years ago, we celebrated our 40th anniversary, something that we're quite proud of. We are essentially a coatings manufacturer. Polymers are the backbone of everything that we make. We have solutions for every surface of a building. I'm talking indoors, outdoors, floors, walls, roofs, and ceilings. Obviously, today I am here to speak exclusively about one of our systems that is specific, of course, to exterior walls. Last but not least, we are founding members of the EIFS Council of Canada. That is our industry association nationwide. We are a founding member, and I currently sit on its board of directors. So enough about us. Now I'd like to get into the presentation itself. I'm here to introduce you to PUCCS NC. For those of you that are not already familiar with it, the system is currently in its third year on the marketplace, so some of you might have had an opportunity to learn of it or maybe even use it on a project on one of your buildings. In a nutshell, what PUCCS NC is non-combustible continuous insulation rainscreen cladding. It includes, to use code language, both your first plane and your second plane of protection from precipitation. Of course, that also includes a 10-millimeter drained airspace required by many entities across the country. And last but not least, of course, is what the backbone of this entire system, which would be our PUCCROCK mineral wool insulation. So if you look at the illustration that you see on the screen right now, what you'll see at the bottom are, number one, a variety of substrates over which the system is commonly installed, obviously intended for use in non-combustible construction. And when you look at the system itself, starting from the inner side or the back of the system, going over the substrate, first would be our water resistive barrier, or WRB for short. That would be, to use code language, the second plane of protection. Of course, outboard of that, then you have the PUCCROCK insulation. Then you have, on the outer face of the insulation, the lamina, which consists of the reinforced base coat and finish coat. That is, in a nutshell, the basic system without any of the bells and whistles. The other thing I'd like to take the opportunity to mention is code compliance for this system. For those of you that are designers and the like out there watching this presentation, DuRock is a firm believer in having our systems evaluated for code compliance before we put them on the marketplace. And with this system, we did as we have in the past with our other systems. Some of you might be familiar with our PUCCS system in particular. We are the PUCCS people. And what we did with this system, we took it to Ottawa, specifically to the National Research Council of Canada, to have them evaluate the system. CCMC, for those of you familiar, a division of the NRC, Canadian Construction Materials Center, evaluates what the building code calls alternative solutions, and they did such an evaluation on this system roughly 2 years ago now. But in order for them to evaluate it, we first had to demonstrate to the people in Ottawa that this system has the ability to self-seal around fasteners, because obviously this is a mechanically fastened system. And we did so by having the system tested at the NRC laboratories in Ottawa. They did the testing themselves. And of course, it met all of their criteria, and that's why we were able to have the system evaluated. Like I said, all of this occurring, give or take, 2 years ago now. So the backbone of this particular system is what we call PUCCS insulation. It is a grooved board on the backside. To be more specific, it is 10mm deep grooves. To use code language, the grooves are referred to as a geometrically defined drainage cavity. That's a codified term now. That's what's on the back side of the insulation for drainage purposes. For those of you familiar with our PUCCS system that we've been doing in combustible polystyrene insulation for better than 15 years now, the drainage cavity that you see on the screen in the backside of the mineral wool insulation is identical to the drainage pattern on the backside of the foam we've been doing all these years. Flipping over now to look at the front side of the insulation board, we've done something kind of different and unique here. We have laminated a fiberglass mesh to the front face that assists in two aspects. First, it assists when it comes to fastening the system. As I mentioned, the system has to be mechanically fastened. So now when the insulation board is fastened to the substrate or the backup wall, simultaneously that mesh is being fastened. That's important as it relates to the performance of the system and the installation of it. And not only that, it greatly enhances the impact resistance of the system, something that I will touch on in a little bit as well. So I'd like to just very briefly go through the functions that this system performs. As with pretty much every EAF system on the marketplace, we're talking about something that is integral to the building envelope, and of course, integral to environmental separation as it is defined or building codes. So once again, the first thing I'd like to touch on is, of course, this system, as with every other EAF system, does a wonderful job of keeping the rain out. That is the primary function that CCMC evaluates the system for. Obviously, it is a cladding, and claddings must, without exception, keep rain out in all Canadian climates from coast to coast. The next thing I'd like to touch on, of course, is the insulation itself. PUCCS NC, once again, as with every other EAF system, the backbone of the system is the insulation component, because don't forget, the I in EAFs stands for insulation. This insulation, as with most other EAFs insulation boards, are available in thicknesses anywhere from 2 inches up to 6 inches, so they can greatly enhance the thermal performance of any building clad with the system. The next function that the system performs, of course, is controlling air leakage. As we know, buildings, the exterior of buildings must be able to control air leakage by virtue of an air barrier. And this system is no different in that regard. As with every other EAF system, this system includes an air barrier component, specifically the WRB, or water resistant barrier, also functions as an air barrier for any wall assembly that it is applied to. Once again, very important as it relates to airtight buildings and energy efficiency in all. The next thing I'd just like to touch on quickly is vapor diffusion. This system and every component of it is vapor permeable. So we've got a completely vapor permeable system that will not trap any moisture within the underlying wall assembly, something that's very important for those of you familiar with condensation related problems. The flip side of this, of course, by permitting the vapor diffusion, also at the same time, don't forget putting insulation on the exterior side of any assembly brings the dew point of the heated indoor air outward. If there is enough insulation on the exterior, that dew point now is brought to the exterior of the building, in which case the underlying wall assembly never gets cold enough for condensation to occur. So even if you don't have a proper functioning vapor barrier on the interior, by putting insulation on the exterior, you now negate that problem of condensation occurring in the first place. The next thing, of course, and not not least of lesser importance, is the system's ability to resist fire. As I mentioned, this is a non-combustible cladding by virtue of the non-combustible mineral wool insulation that is included in it. So there are virtually no restrictions as to which buildings this system can be applied on. Any building type and any wall, irregardless of limiting distances or proximity to property lines and the like. And the last thing I would like to touch on very briefly here is the system's ability to resist damage caused from impact. As I mentioned earlier, that layer of mesh that we laminate on the exterior side of the insulation board enhances or increases the impact resistance of the system. The system is more impact resistant than your typical or basic EAF system, and also has the ability to increase the impact resistance in those areas that may need additional resistance. So from a functioning perspective, as an integral part of the building envelope, as it relates to environmental separation, this system performs any and all of those functions. Time does not permit me to drill down deeper into each of one of those aspects. That's something that I would gladly do at a later time if anyone would like, or if anyone would like, please, if you have any questions on any aspect of the presentation, please enter them in the chat room and I will try to address them at the end of the presentation. The next thing I wanted to touch on is a buzzword that we hear all the time out there, and it is sustainability, or to be more specific, sustainable design. So I've put up there on the screen what sustainable design means to me as it relates to buildings. Sustainable design seeks to reduce the consumption of non-renewable energy, in other words, fossil fuels, thereby reducing greenhouse gas emissions, or in other words, the carbon footprint of the building. And as I've hopefully demonstrated here today, when it comes to our PUCCS NC system, or for that matter, any and all EAF systems, they, by virtue of the insulation and the air barrier component, they do go a long way to reducing the amount of energy that any building clad with them is going to consume. As we all know, you've probably heard already that buildings consume at least 30% of the world's energy. I have heard numbers as high as 40%, but we are talking no less than 30%. So any amount by which that number can be reduced will go a long way to making our society and our buildings sustainable. The other buzzword that I wanted to mention, if you excuse me for 1 second, please, is resiliency. It's another one of those words that we hear being used quite often. And once again, what I put on the screen here is what resiliency means to me. To me, it is the capacity of a building to function under extreme conditions, such as those attributable to climate change. Now, there are a few truths that we now know about climate change. Number one, those events are happening more frequently. And two, they are happening with greater severity. So if buildings are going to be resilient, in other words, if people are going to be able to remain living in those buildings when these events occur, the buildings are going to have to be more resilient than the current stock is presently. Some of you may be aware, EAFS has 3 standards referenced in the building code, both in the national and in the provincial codes. I'm not going to go into each one of them in any great depth here and now because time does not permit. I just wanted to touch very briefly on one of those standards. It is CAN ULC S716.3. It is a design standard. It is, to the best of my knowledge, the first design standard that existed in Canada, and if I am not mistaken, it is still the only one out there, at least that I know of, that is referenced within our building codes. That standard has an informative annex, and that annex addresses things like resiliency. It addresses passive survivability, thermal bridging, air leakage, and Sorry, I'm getting some background noises here and I'm not sure what they are. Passive design. Talking about passive survivability, that brings me to design, is the next topic I wanted to touch on. And of course, as everyone here is familiar with, when it comes to passive design, the cornerstone is or are well-insulated, airtight buildings, which is what our PUCCS NC system, and furthermore, all EIFs are all about. For one other thing I'd like to mention as it relates to well-insulated buildings, our system is not negatively affected by some things that are some thermal bridges that negatively affect competing alternatives. I'm talking specifically about girths, shelf angles, and anchors. For those of you that have used other claddings in conjunction with mineral wool or non-combustible insulation, you have sometimes significant thermal bridging caused by those elements, which our system does not have, making it more thermally efficient. I wanted to take this opportunity to highlight a few projects or a few of the prominent projects that have been done with our system. Building owners all over the country choose this system because, number one, first and foremost, obviously, is its superior fire resistance. And not only that, the peace of mind that the system affords during the retrofit of occupied buildings, not only to the building owners, but also to the residents, the people that are living and sleeping in those buildings while the work is ongoing, and of course, afterward. So the projects, there's only a few that I wanted to highlight here today. And the first one up, as many, it should come as no surprise to many of you, and that is the Ken Sobel Tower in Hamilton. I hope some of you were able to catch the presentation this morning that was centered around that building. That building was clad with our PUCCS NC system. We are very proud to have been involved in that project because of everything that has to do related to Passive House and the Retrofit certification. And we were just glad that we could do our small part. I also wanted to just quickly showcase some apartment buildings in Sarnia, Ontario. There are 3 buildings in total. They are all 12 stories. Once again, a retrofit. As with the Ken Sobel Tower, we're talking about retrofits going over the existing brick facades of the building. The next thing, the last project that I wanted to take time to mention today is one in Toronto. For those of you from the Toronto area, it's in the St. Clair and Yonge Street area, specifically 49 St. Clair Avenue West, and it is a 7-story, and once again, an existing brick building that was overclad with PUCCS NC. I would imagine many of you are familiar with this picture. This is the Ken Sobel Tower in Hamilton, 18-story building that was retrofit with this system. Interesting to note, I don't know if it was mentioned this morning, but the project started in 2019, at least the exterior part. The air barrier was applied in the construction season of 2019, and the cladding was installed in the construction season of 2020, all in one construction season without supplemental heat, I might add. What you see now on the screen are those Drulo apartments in Sarnia. There are 3 buildings. They all more or less look the same as the one that you see on the screen right now. And for those of you from the Toronto area, that is the building at St. Clair and Yonge. I'd just like to take a little bit of time to mention where our information is available. As with every manufacturer, you will find our system specifications on our website. You can also find our CCMC evaluation on our website. Once again, not only for this system, but for all of our systems. When it comes to construction details, we try to do something a little bit different to assist the designers when it comes to using our systems. What we've done for our garden variety details, we have CAD drawings, 2-dimensional details, and 3-dimensional illustrations for each and every one of our systems and for each and every construction detail. So what we have is a corresponding detail and illustration for every CAD drawing. So as a designer or an end user, you can go and look at the illustration to know what you should be seeing on your building, and then you can use either the corresponding detail or CAD drawing in your construction drawings. One thing that we realize is that there are many conditions on many buildings that are obviously not representative of what we have on our website. And for those details, we offer a service of providing project-specific shop drawings upon request. All that we ask designers to do, very simply, send us your architectural detail and we will fit our system into your detail. Very quickly, just to show you, when I was talking about those 3D illustrations, there's a sample that would be our PUCCS NC system with the PUCCROCK insulation. These are two alternative window head details, just so that you can see them, so you can appreciate them. Sorry about that. And here would be a typical two-dimensional illustration that would correspond to the illustration that I just showed you. The last thing I wanted to touch on very quickly is related to aesthetics. When it comes to EIFS, or DuRock's finishes for that matter, number one, they are available in infinite colors. Most of our finishes can be tinted to any color under the sun. We have a multitude of textures, so there is no need for the finish to have that stucco appearance, if I will. Actually, I would prefer if our systems look like anything other than stucco. Our finishes can simulate other common commercially available finishes like brick, stone, granite, and yes, even wood. So once again, there's no need for EIFS to look like stucco, although it all often does. The one thing that I'd like to mention before I show you these couple of pictures that I have is that pictures do not do justice to these finishes. So what we will gladly do for anyone who would like to actually see a physical sample of whatever finish it is that you may be interested in, we will gladly prepare those and send them to you so that you can actually see, feel, and touch the product instead of just looking at pretty pictures. So when I mention that we have finishes that can resemble brick, that is our PUCCS system with a brick finish on it that is not real brick. When I mentioned block or stone, or in this case, if people want that Indiana limestone look, that is very simply done as a finish over our system. And if people want something that has that granite look, that shimmering look where it catches the sun's rays, we also have those finishes as well. I would like to take this opportunity to thank everyone for your time. Once again, any questions, please put them into the chat and I will address them shortly. In closing, the only thing that I would like to say, once again, this is a non-combustible cladding system, inclusive of its insulation. It's ideally suited for our aging building stock that, as we all know now, is in desperate need of retrofit if we are ever going to reach our net zero emissions goal. So with that, I thank you, and I will now switch. Sorry, so I was talking about, let me go back there, about as far as installers that are trained, there are a number of them across the country that are trained. There are, like I said, there are more than ample number of contractors out there. In fact, what we ask prospective clients to do is to contact us when you have a project. We will gladly refer contractors to price the actual work so that you are not relying on anyone and everyone out there who may price the work, because just as with every other trade, there are good contractors and there are bad contractors. So please, by all means, do take advantage and use the contractors that we would gladly refer to you. And the next question that I see is about embodied carbon rating, ratings. That is something that the industry as a whole is currently working on. As I mentioned at the outset of the presentation, I am a member of, DuRock is a member of the East Council of Canada. I sit on its board of directors. We are actively pursuing these carbon ratings. but we do not have them yet at this point in time. Hopefully, they will be forthcoming shortly. I have another question. Does it have a unique or special install needs beyond other materials that may be used? I believe I've already addressed that by making sure, just as with any trade, this system should only be installed by a specialist trade contractor. This is not a do-it-yourself product for use by general tradespersons. What percentage of the wall area is open for drainage and drying? It appears that the area is greater than the vented drainage space. Yes, for those of you familiar, if you look in the building code, what you will find is a minimum of, I believe the building code, if it's been a while since I've checked, I believe it says 13% is the minimum open area for eaves in accordance with Part 9 of the building code. Our PUCCS system far exceeds that minimum 13%. In fact, we have a 37% open area in our PUCCS system. And once again, that applies to whether we are talking about the foam system with the combustible polystyrene or the mineral wool system. I have a few more questions hopefully I can get to before we run out of time. Do we have any non-combustible components? Oh, I just lost the question. Sorry about that. Do you have any combustible components at the slab bypass for window systems? Are you strictly eaves type walls? Yes, we don't. We use, whether it's the foam insulation or whether it's the mineral wool insulation, they are used as components of our system. I believe this question may be related to fire blocking or fire stopping, and that is, although the insulation that we use may be used for those purposes, is not something that we do as a company. How many stories can you span without through-wall flashing on a wood frame building? That is typically left to the discretion of the designer. It is entirely at the designer's discretion whether they would like to flash at every floor line or only at certain floor lines. Again, entirely their discretion, as long as the system can drain to the exterior at some point on the wall assembly, whether it's at every floor or not. Can you provide details about material composition? That is something which I would probably have to get back to someone at another time, not something that I can probably address here and now. There is a pre-con tool development called estimate. That is something I'm not familiar as well. I will have to, once again, I apologize, get back to someone regarding that. For the simulation of the stone look, would the reveals have lower R value and can be weaker insulated? As far as the reveals that you saw, whether we were looking at the stone finish or the brick finish, those reveals were only in the finish. They did not transfer into the insulation material themselves. So the insulation was fully continuous insulation and was not negatively affected by any reveals, at least in those illustrations, although reveals are sometimes used in other finishes for aesthetic purposes, and they may slightly diminish the R value, but not to any great extent, because typically, number one, they are not very deep, number one, and number two, they are usually spaced quite far apart. And with that, I believe I have addressed at least all of the questions that I am able to address right now. So once again, I would thank everyone for their time and wish everyone a wonderful day. Thank you very much, everyone. Bye-bye.